Good afternoon. All right. Thank you. All right. So let's see. Looks like we're missing Aiden and all of Mogollon High School.
Aiden told me to tell you that he was at a soccer game. He just forgot to email you.
Okay. All right. Thank you. Well, let's see what happens. Um, Here. So 3, 4, 5. All right. So let me, I guess first, let me talk for a second to, uh, this is actually for everybody, but Chloe, you were asked for the video from last Thursday.
Yeah.
And it was, let's see, it was for 3.4a on Thursday the 10th. I don't know if any of you others of you are wanting that video or to review that material, but we're actually having an issue with that video, so I don't know if it either, according to um, the tech support, they can't find it. And it just so happens the expert guy that I have 100% confidence in that if it could be found, he would find it. He happens to be on vacation this week. So just when we need him, right? So that's why I said just go ahead and get the notes from Skylar, and then if we so if I get an answer one way or the other, that like if this video exists, then I'll post it, and then I'll email you or tell you in class that it is. If the video didn't get recorded that day for some reason and it's just doesn't exist, then what I'll do is I'll let you know that too, and then at that point, if you get the notes from Scholar, then I'll count your attendance as good that day.
Okay, thank you.
So you'll be covered either way. You're welcome. Okay, so let me check and see what the deal is with Mogollon, if we think that they're going to be coming on board or not. So just give me 1 second. I'm going to call the support center. Okay, so we're gonna be patient for a few minutes. But so while we're waiting for a couple minutes, does anyone have any? Everybody okay for? Oh, see, I just got a text from Moyan. If Does anyone have any questions about anything? Any issues as far as the tests, or not the test tomorrow? Yeah, we're taking the chapter 2 test tomorrow. So I was just gonna. So let's see. So mostly everyone is at 150 to 250. Let's see. Is that right? Yeah. 150 to 250. Is that? Oh, let's see. Um, oh, okay. So in Winslow, you guys have kind of changed me up a little bit on test times. Is 150 to 250 good for you, or do you want it in the morning? You had one time it was 8:45 to 9:45. So what would be good for you guys for the test?
Um, Miss Lopez isn't here today. We have a substitute, so we could do it in the morning at 8:45. But
Okay.
we're not sure if she's going to be available, so we can probably just do it after class tomorrow.
Well, if they don't, if do they for the substitute for Miss Lopez, did they sub all day? I mean,
Yeah, but 8:45 to 9. We have a late start tomorrow, so we come in before
okay.
school.
Okay. Well, so why don't we should we set it up after class then tomorrow?
That's fine. Yeah, that's okay.
Okay. And then if it's any different, if you find out any differently, then actually on Wednesday mornings, a lot of times I'll be away from my office, and so it's actually you better to reach me by texting me. Okay. So if you've got my number in the syllabus, so anyway, text me if there's an issue. Otherwise, we'll just set it up then. So for after school tomorrow. All right. Any other issues? Okay. Any questions? I'll tell you what I'm thinking about doing is I think I'm gonna go ahead and we're gonna finish 3-4. We just have like 5 to 10 minutes, and then if Mogyan hasn't joined us by then I'm probably gonna cancel early because I kind of have this rule that if 50% of my students aren't present for any reason, then I don't teach new material. So I'm going to give them a little bit of time to get their Wi-Fi issues up. And so I kind of want to be patient, but on the same other hand, I don't want to, anyway, I don't want to go on to 3.5 if they're not with us. So we're going to just kind of roll with the flow here. Okay. So we are on part 5, derivatives in economics. So that's on the back side near the bottom of the first column. Let's see. Now I have not had, we've had some issues with the board here today. So let's see if I can actually teach at the board. Oh, we have Mogyan back. Okay, good. All right. So I was getting a little worried. They weren't quite sure what the internet situation was. So let's see. We've got Hannah is not here, and anybody
Yeah,
else?
Hannah and Rachel are both gone.
Hannah and Rachel. Okay.
Yes.
All right.
Hannah
All
Z,
right.
not Hannah W.
Hannah Z. Okay. All right. So we're just and we're good. So Mogyan, we're good for the test tomorrow, regular time,
Yes.
right
We're
before
good.
class. Okay.
I'm
Awesome.
gonna try to get Cadence on right now, see if she can get it done.
Okay. All right. Well, with the issues we've had today, Miss Townsend, you never know. So it's like if NBC hasn't had the technical issues, it's been you guys. So we can't hardly win today. So let's cross our fingers for Cadence, right? So anyway, okay. So so derivatives in economics. So economists have a specialized vocabulary for rates of change and derivative, and they're called marginals. So when you see the word marginal, it means take the derivative. So a marginal cost is the derivative of the cost. The marginal revenue is the derivative of the revenue. The marginal profit is the derivative of the profit. So when you see that word marginal, that means take the derivative. All right, so if we have the cost function, the marginal cost is like the slope of the tangent at a specific point. Now, so technically, like the C of 100 would mean to plug 100 into the cost function. So that would be the cost of making 100 items, of producing 100 items. The cost refers to you're the producer, you're the manufacturer. Okay, what it costs you to make 100 whatever. The C prime of 100 means at that point, what would be the approximate cost for the next one? Okay, so for the next one, so if we're making 100 pizzas, the C of 100 is the cost of making 100 pizzas. C prime of 100 would be, after we've made 100 pizzas, about how much would the next pizza cost? Okay, so that's the idea there. All right, so let's say we're given this specific cost function, C of x, okay? So the marginal cost of the 100th sprocket would mean take the derivative and then plug in 100, okay? So if we take the derivative, the 20,000 goes away, the derivative of 5.2x squared would be 10.4x minus 4. So that's the derivative. So then we plug in 100, and the C prime of 100 would be 1,036. So that means the next sprocket would cost approximately $1,036, whatever. So who knows what this, you never know. I don't know if I told you this, I went to an engineering company where they machine parts and everything, and they had one part that was actually a rejected part from the Department of Defense, and it cost them like $500,000 for one part. Now it turned out that it was a part of a nuclear device, so they kind of had to be accurate on it. So anyway, okay, so let's look at, or any questions? All right, so let's try practice 5. Okay. So here I'm giving you a cost function and a revenue function. All right, so see if you can figure out what you have to do for each one. All right, so Rhett, what is the marginal cost function?
Do you just take the derivative, or do you have to plug
Yep.
something in?
Nope, just take the derivative of the cost.
Okay, so 3x squared minus 10x plus 10.
Yep. Okay? So everybody cool with that? All right. So then the next one says the estimated increase in revenue. Okay? For selling 12 widgets. So the estimated increase in revenue, that's the same thing as asking for the marginal revenue, which means take the derivative of the revenue at 12 widgets. All right, Rhett, this one's all about you, brother.
$772.
There it is. Good job. And that's in dollars. Okay, so there you take the derivative of the revenue function, then plug in 12 and work it out. Okay? So, any questions on that? All right. Wonderful. Okay, so to get some feel for the language of marginal rates, consider marginal tax rates. Okay? Now this is, kind of an example, a perfect example of our tax code, is they'll use words like marginal tax rate, and really, it's so easy, but it's the wording, the language is complicated. You feel like it's a difficult problem, and it's just like, really? Do you just take the derivative? Okay, so it says if your current income level is I and your taxes are T, how would you write a marginal tax rate of 28%? Okay, so here you'd say, okay, I is your income, T is your taxes. So if T is 0.28I, then what would, this is your, so if this is your taxes, so what would be your marginal tax rate?
0.28.
0.28, okay? But see, that sounds like such a complicated thing. So 0.28, so you just take the derivative. So the derivative of 0.28I is just 0.28, okay? All right, so go ahead and do practice 6. All right, Joran. What do you think?
0.27 is equal to t prime.
That is correct. So, is it that the question was easier, or is your brain working better today, Joran? What do you think?
My brain is working today and there's less distractions around me, so.
Okay, awesome. Awesome. All right, well, good to hear. Any questions on that? All right. All right, so this is the last thing. When a small change in x produces a large change in the value of the function, we say that the function is sensitive to change. So, like for example, let's say that this is my equation. Y equals 2p minus p squared. Okay? So then the derivative of this would be 2 minus 2p. All right, so what that means is if we change p, or the x value, by, say, 0.1, then to figure out how y is changing, you plug that into the derivative. So you plug in 0.1 here for p or x or whatever the value is. 2, so 2 minus 2 times 0.1. So you get 2 minus 0.2, or 1.8. So that means that if you change the value here by just 1/10, then the y value changes 1.8. So 18 times more. So one little tiny change in x produces a huge change in y. So we say that it's very sensitive to change. Or how sensitive is it? Well, it's 18 times if you go from point 1. Okay? So let's see if you can do practice 7. All right? So actually what I'm asking you to do here is to graph y prime. So take the derivative and then graph it in your calculator. Or you can do it by hand, I suppose. All right, so Davin, what's the derivative? What's y prime?
Ten minus 2p.
Okay. All right. All right, so then graph it. Now, I also want you to use 0.1. So if the p changes by 0.1, I want you to tell me how is the y changing. All right, so Denon, so you answer that one. If p changes by 0.1, then how much is y changing? So Denon, if you plug in 0.1 here for p, then what's y going to be? Or what's y prime?
9.8.
9.8. So what that means is that the value for p, again, if you change it by 1/10, you're going to change this by the y value by 9.8. So it's 98 times more sensitive to change. So if you change the x value just a little bit, the y value changes by a factor of 98. Okay? So that's very sensitive to change. Okay? So anyway, any questions on that? All right. Well, that's it for 3-4. Any other questions on 3-4? Now, remember, tomorrow we're not doing quizzes on chapter 3. We're doing the chapter 2 test. Okay? So, are we all good for the regular times? So, Jordan in the morning and Hannah W. and everybody else right before class, right? Yeah, sweet. Okay, so we already confirmed with everybody else. Okay, well, let's go on to 3.5, which is derivatives of trigonometric functions. Okay. All right, so as we go, we're going to go through all 6 trig functions and the derivatives. Now, these I would recommend that you memorize. Okay, it will really help down the line if you know the derivatives of the 6 trig functions. We'll go through them and we'll practice a little bit, but these are ones that I recommend, getting flashcards or whatever. These you're going to want to memorize. It'll help you down the line. I promise you'll be glad that you take the time to do it. All right, so we're going to start with the idea of periodic functions. Many phenomena are periodic, such as spring, school, time. Why is one spring lowercase and the other spring uppercase? What am I talking about there? What's the difference between a lowercase spring and an uppercase spring?
Is spring like the action and spring is like springtime?
Yeah, and or like a spring, like the physical thing, a spring. So that's when you have an object on a spring, we're going to learn that, like, if you stretch it out and let it go, well, its motion is going to be periodic. And then, like school, where the idea of a repeated activity that goes through a cycle. Time. The derivatives of the trig functions play a key role in describing periodic changes. As a matter of fact, there's actually a way that you can write every function as a sine function. And so it really, as far as, when you go into like quantum physics and so on, the idea of trig functions are huge, okay? Because you can even express things like, we don't think of like light and sound, but, well, maybe sound, you've heard of sound waves, but light is also can be described as a wave. Even concepts like time can be considered as like a wave. Anyway, I don't want to get into too much quantum physics here. But let's start with the first one. So the derivative of the sine function is the cosine function. Okay? So this is how they write it in the book. This is how I remember it. Is I'll say y equals sine x, so y prime is cosine x. But just know the derivative of the sine function is the cosine function. And oh, that they were all that easy. But we've got to start somewhere. Okay? So, if I wanted to say take the derivative of y equals x squared minus sine x, well, you just do it term by term. So you say y prime is equal to 2x minus, and then the derivative of sine x is cosine x. All right, now this one's a little trickier because it's 2 functions that are right next to each other. There's no plus or minus. So to do this, I have to use the product rule. Okay? So think of like x squared as your u, your sine x is your v. Now, when you're first, you might remember this, that when you're first doing the product rule, it actually doesn't hurt to write down what the u and the v are, and then the u prime and the v prime. So if u is sine x, u prime is cosine x. V is x, so v prime is 1. So then when you're doing the derivative, you say, I'm going to take the derivative of x squared, which is 2x, times sine x, plus x squared times the derivative of sine x, which is cosine x. And that's it. All right, now the third one is sine x divided by x. So you can see it written like this with the slash or with the quotient bar. But either way, on this one, you're going to have to use the quotient rule. So we start, when we're taking the derivative, you start with the denominator. So you say, okay, y prime equals x times the derivative of the numerator, which is cosine x, minus the numerator, which is sine x, times the derivative of the denominator, which is 1, all over the denominator squared, which is x squared. Now, you really can't simplify that much other than sine x times 1 is sine x, and so that would be how you'd write your answer. All right? Any questions on those examples? All right, let's go ahead and try practice 1, all 3 parts. And I'll leave it up here for just a minute. All right, Skylar, what do you have for the first one?
Y prime equals 3x squared plus cosine x.
Beautiful. Okay, any questions on that one? Okay. All right, let's see, Nathan. Do you have B?
Yeah. Y prime equals 3x sine x plus x.
Wait. It's going to be
Oh, wait.
3x squared.
Squared, sorry.
Okay.
3x squared plus x cubed cosine x.
Excellent. Any questions on that one? Okay.
I can't find the multiplying rule, the rules.
The quotient rule?
Oh, yeah. I'm trying to find which lesson it's in. Sorry.
It's 3.3.
Okay, thanks.
All right, so Rhett, when you've got it.
3x squared sine x minus x cubed cosine x over sine x squared.
Excellent. Any questions on that? Anybody want me to go through it? All right. Well, good job, Rhett. What?
Sorry, no, that was an accident.
All right. Okay. Just don't be like screaming or something, freaking us out. All right. Next. So the derivative of the cosine function is the negative of the sine function. Okay. So this is how the book writes it. D dx cosine x equals negative sine x. This is how I write it. If y equals cosine x, then y prime equals negative sine x. Okay? Okay? Now, a couple of things here. Number one, the derivative of all of the cofunctions are all negative. Okay? So they're going to be negative. So anytime you have any of the three cofunctions, their derivative is negative. Okay? It actually took me like 10 years to realize that. Okay? I don't know why I never saw that pattern. Okay? In the trig derivative formulas, x is measured in radians. Okay? That's also important. So we're always going to be in radians. All right? And then finally, it says, the last one says, the square of a trig function can be written as sine squared x or parentheses sine x squared, but not sine x squared like that. What does sine x squared mean without the parentheses? What does this mean? What are you actually squaring here at the bottom?
You're squaring the x, not the sine of x.
Right. So this means x times x, then take the sine of it. Whereas this means sine of x times the sine of x. So if you're trying to raise the power, a trig function to a power, you have to write it in one of these two ways. So we're going to have to deal with that in just a few minutes. All right. All right, so derivatives involving the cosine. So just kind of look for any kind of trickiness here. So here the derivative, you do term by term. So the derivative of 5x is 5. The derivative of cosine x is negative sine x. Okay, pretty straightforward. All right, now look at this one. Sine x times cosine x. Again, we're going to need the product rule here. Okay, so we take sine x times the derivative of cosine x, which is negative sine x, plus the derivative of sine x, which is cosine x, times the cosine x. So now we write that as negative sine squared x plus cosine squared x. Okay? And then the third example, let's say I had cosine x divided by 1 minus sine x. All right, here we're going to need the quotient rule. So we start with the denominator, 1 minus sine x, times the derivative of the numerator, negative sine x, minus the numerator, cosine x, times the derivative of the denominator. The derivative of 1 goes away. The derivative of negative sine x is negative cosine x, all over the denominator squared. Now, don't square out the denominator, because we want to leave it like that in case we can cancel it. So don't square that out. But the numerator you do want to simplify. So here we distribute the negative sine x. So negative sine x times 1 is negative sine x. Negative sine x times negative sine x is sine squared x. Negative cosine x times negative cosine x is positive cosine squared x, all over the denominator. All right, so is there anything we can simplify from there? Any Pythagorean identity that you see? Okay, you guys don't be working on the practice problems yet. You're going to need to see this example, because this will make a difference in how you're simplifying these. Okay? Okay. Go ahead.
Cosine 1 minus sine x equals cosine x, right?
If you're interested in doing the Stephen program
no.
next semester,
Cosine
come
squared
see
x.
Ms. French this
Okay.
week.
So
Stephen's interested in doing the nursing assistant program.
okay, thank you. So sine squared x plus cosine squared x equals what?
Tangent.
No, sine over cosine is tangent.
Tan squared x.
No, that's the next Pythagorean identity. The very first Pythagorean identity. Now, and this one I did ask you to memorize too, or maybe it's just my trig students I asked you to memorize it. Sine squared plus cosine squared equals 1. Okay? So, if you didn't know that, write that down right now. Okay? You've got to know that sine squared x plus cosine squared x equals 1. And so then when we substitute that, make that identity, then what we're going to get here is 1 minus sine x. Now, Lee, how are you supposed to concentrate with all that racket going on?
You really can't.
Anyway, that's too loud for me. Okay, but look what amazing thing happened. So then we're left with 1 minus sine x over 1 minus sine x quantity squared. So this whole thing will cancel with one of these. And so my answer is just 1 over 1 minus sine x. So that's why we never multiply out the denominator, just in case we can cancel. Okay? All right. So I'll leave that one up there. You guys try practice 2, all 3 parts. All right, Jordan, what do you have for A?
Y prime equals 10 plus sine x.
Excellent. Okay. And I'm really happy every time you guys say y primes. Okay, when you're taking the derivative. So good job. All right, next. Joey, B.
Okay, is it sine squared of x plus or minus negative, or yeah, so plus negative cosine squared x?
Okay, so sine squared x minus cosine squared x. So either way, that will work. Okay. So negative cosine squared x plus sine squared x, that's the same thing as what you said. So good job. All right, the last one. All right, Joran, we're really testing your brain today. All right, so what did you get for C? Or when you've got it, let us know.
Alright, so this is a really long answer, but I don't think you can simplify it past this point.
Okay.
So 2x times cosine x minus 2x times sine x minus 2 times sine x plus 2 times cosine x divided by sine x plus cosine x.
Okay. So I think you said all of that. So you could, so distributing the two is good because sometimes you can combine like terms. Or sometimes leaving it factored is good if you think you can factor, but there are no like terms and there's nothing to cancel. So that means it doesn't matter if you distribute the two or not. It really doesn't matter. Okay. I think you said all of that. 2 sine x plus 2 cosine x minus 2x cosine x plus 2x sine x all over sine x plus cosine x quantity squared. Okay? Did we get that, Jordan? I think you had that right.
Yes. Yes, I said that all.
Okay, wonderful. All right. Well, let's give you, if we don't drop off, let's just give you the one blank to fill in, and then we'll pick it up from there tomorrow. So it says the motion of a body bobbing up and down at the end of a spring or a bungee cord is harmonic.